let's talk about colligative properties. So what are colligative properties? So colligative properties are those properties of solution that depend on the ratio of the number of solute particles to the number of solvent particles in a solution, and not on the nature of the chemical species present. So colligative properties are simply properties of solution that depend on the ratio of the number of solute particles to the number of solvent particles in a solution. Okay, so these colligative properties, we have the vapor pressure, melting point decrease, boiling point increase, and osmotic pressure. So in this video, I'm going to show you how you can calculate vapor pressure, and in other proceeding videos you are going to see how we can calculate the freezing point, the boiling point, and osmotic pressure. So what is vapor pressure? So vapor pressure is simply the pressure exerted by a gas or a vapor released by a liquid or solid in a closed container. So if you have a closed container, the pressure that a gas or the vapor released by a liquid or solid exerts on the container is what we call the vapor pressure. And this vapor pressure can be calculated using this formula here. So this formula says the vapor pressure of the solution is given by the vapor pressure of the solvent multiplied by the mole fraction of the solvent. So the vapor pressure, which is P solution, stands for the vapor pressure, and the P solvent is simply the vapor pressure of the solvent in which that solute has been dissolved, and this here is simply the mole fraction of the solvent. So mole fraction is given by the formula, the number of moles of that solute dissolved in that solution, and the moles of all components in that solution. So for example, if you have a solution which has components A and B, then the mole fraction of A will simply be the number of moles of A over the number of moles of A over the number of moles of A plus the number of moles of B. So that will be the mole fraction of A. So let's have a problem. We see how we can use these formulas and how we can calculate the vapor pressure. So we have this problem which says calculate the vapor pressure of a solution made by dissolving a 218 grams of glucose, which has the molar mass of 180.2 grams per mole, in 400 ml of water at 30 degrees. And we have been given that the vapor pressure of water at this temperature is simply 31.82 millimeter mercury. So the density of the solution is also given as 1.0 grams per ml. Okay, so let's calculate the vapor pressure. So to calculate the vapor pressure, we first need to have the mole fraction. After finding the mole fraction, we are going to replace in this formula here, which is mole fraction multiplied by the vapor pressure of the solvent. And in this question, our solvent is water, and the vapor pressure of water here, the vapor pressure of water has been given to be 31.82 millimeter mercury. So what is the vapor pressure of this solution? So to do that, let's first identify what we have been given in this question. So in this question, we have the mass of glucose, which is 218, and we have the volume of the solvent, it was 460 ml, and the vapor pressure of water, which is the solvent, was given to be 31.82 millimeter mercury. The density of the solution was 1 0.00 grams per millimeter, and the molar mass of glucose was given. So let's first find the mole fraction, which will help us to find the vapor pressure of that solution. So to find the mole fraction, we will need the moles of the components which are in that solution. So in that solution, there is glucose which has been dissolved in water. So we are going to find the number of moles of water. Thereafter, we are going to find the number of moles of glucose. After finding those two, we are going to find the mole fraction. From there, we are going to find the vapor pressure. So to find the number of moles of water, we need the mass of water. So the number of moles, the mass of water, remember the number of moles is given by the mass over molar mass. So, but on our data here, we only have the density of the solution and the volume of water, which is 460 mils. So we are going to calculate the grams of water. From there, we are going to find the number of moles. So to find the mass of water, we are going to use the density of that solution and the volume, so that we replace in this formula to come up with the mass of water. So the density is given by mass over volume here, and to make mass the subject of the formula, we're going to have mass is simply the density multiplied by the volume there. So the density we have already been given, which was 1 gram per mils, and our volume is simply 460 mils. So multiplying the two, we are going to have 460 grams of water. So to find the number of moles, we are going to replace the mass over molar mass. So the molecular formula of water is given as H2O. So the molar mass of oxygen is 16, and the molar mass of hydrogen is simply 1. And here there are 2, so the molar mass of water will be simply 18, and the mass of water, we have found it to be 460. So replacing in this formula, the number of moles should come out as 25.6 moles of water. So we have the number of moles of water. So let's find the number of moles of glucose. So the number of moles of glucose will be the mass of glucose, which is 216 grams, and the molar mass of glucose we have already been given in our question. It was 180.2 grams per mole, and dividing that, we should find the number of moles of glucose to be 1.21 moles. And then from there, let's find the mole fraction. Then we said the mole fraction is given by the formula moles of water over the sum of moles of the solution. Remember, we are finding the mole fraction of the solvent, which is going to help us to find the vapor pressure. So we are going to have the moles of water, which we found to be 25.6 mole, and then the sum of the moles which are in that solution. So in that solution, we have glucose and water. So the number of moles of water is 25.6 plus 1.25 mole of glucose. So our mole fraction should give us, will be just 0.53. Okay, so we have our mole fraction. Now we can calculate the vapor pressure. So our vapor pressure is given by the formula, the pressure of the solvent, and multiplied by the mole fraction of the solvent. So the vapor pressure of the solvent we were given to be 31.82 millimeter mercury, multiplied by 0.953, which is our mole fraction we found there. So our vapor pressure for that solution should be 30.34 millimeter mercury. So thank you very much for watching. Remember, don't forget to like, subscribe, and leave out your comment in the comment section below.